Hello everyone, welcome to A1 Tutor live class. Now we'll be having physics. We started a topic last week, which was work, and power. And we did the first part, the second part last week. And today we are taking the concluding part, which is power. We are taking the concluding part, which is what? Power. Work, energy, and power, part 3. We're taking the part 3 today. We've discussed about energy, we've discussed about work done, and we said that work done has to do with the product of force and distance, and that is why the formula is force times distance covered. And we said energy is the ability to do work. Under that, we discussed the kinetic energy and the potential energy. All right, we discussed the kinetic energy and the potential energy. I believe that is clear to us. Okay, in case you had not chance to join us for the class, in case you did not join us for those part 1 and part 2, of course, you don't need to panic, okay? We have the video on YouTube. Okay, just go to YouTube, search for A1 Tutor. You will see the list of all our videos on YouTube. So you can go ahead to watch Work, Energy and Power part 1 and part 2. So today we are going to take part 3, and the part 3 is going to be centered on power. Part 3 is going to be centered on power. When you hear the word power, what comes to your mind? I remember while we were still very small, okay, very small, we do something like this. I have power. I have power, right? Trying to show our friends that we have power by showing our hands. Okay, that's our knowledge of power then. But now, what is even power in the concept of science line? Power is not when you feel like you can beat somebody or you can actually override somebody. No, power has to do with a concept, and we need to understand this concept. Okay, and we are going to explain the concept based on physics, what power is all about. All right, so let's start with um taking a picture to explain what power is. All right, taking a picture to explain what power is. I'm coming. I want to explain the concept of power. All right. Now let's consider this picture. I'm going to send something in our chat. I want you to check. A picture will be sent in the chat. Okay, so let's have the picture now. We are going to have it now. It's loading. All right, and this is it. So once you have access to the picture and you can view it, please, I'll need you to signify by typing yes or thumbs up. It's still loading. You are going to receive it in a few minutes time. Okay, now let's present it, and we're all going to go through it. Now I believe you have access to the picture. All right, thank you, Enoch. Now we are discussing power today, and we said we want to explain what power is when it comes to the line of physics. There's a concept behind it, okay? A simple definition of power is the rate of work done, the rate of work done. And when I say the rate of work done, you should know that there is a time factor attached to that definition. All right. If I say that power is the rate of work done, that is, power is the rate of work done, it means that there's also a time factor attached to it. All right. Now, we have two individuals that have the same quantity of work to do. Okay. We have two individuals, Mr. A, Mr. B. They are to cultivate a plot of land. They are to cultivate a plot of land, the same size, no differences, and the tasks they are given to do are the same. All right. And both of them are to do it simultaneously. That is why Mr. A is doing his own land. Mr. B also will be doing his own land. Okay. Now, between Mr. A and Mr. B, the person that finished first, let's say Mr. A, okay, Mr. B finished first, all right, and he was able to finish the whole land. He was able to cultivate the whole land, and Mr. B finished the second. Who among them has power? Who among them has power? Is it Mr. B or Mr. A? They cultivated the same size of land, the same plot of land, and the land has the same structure, no differences, and they were asked to cultivate it. They started the same time, and Mr. B finished the first, and Mr. A finished the second. So who among them has power? Yes, I need your response in the chat box. Just type A or B. I'm waiting. I need your response. Okay, should I take again the illustration? I said Mr. A and Mr. B were given the same plot of land to cultivate, okay? And this Mr. B finished first. That is, he was the first person to finish. And Mr. A finished the second. So who among them has power? Mr. B. Thank you, Ella, for your response. Mr. B has power than Mr. A because power is defined as the rate of work done. And the rate of work done is the time used in accomplishing that work. It's not what you have done, but the time you spent in doing that work that will determine your power. Are you getting it? So the rate of work done is what? Power. The rate of work done is power. So it is not because you finished your work. The question is, did you actually make use of a long period of time to finish the same work that someone can finish within few minutes or few seconds. Are you getting it? So power has to do with the rate of work done, and that rate has to do with time. It has to do with what? Time. So I will define power as the time rate of doing work, or the rate of work done. So power is defined as the time rate, the time what? Rate of doing work. Of doing what? Work. So the time rate of doing the work is what we refer to as power in physics. Okay, so while we are still small, then I will used to do like this. I have power, I have power. That is not in alignment with the concept of physics. The concept of physics is that the time rate of doing the work is called power. Okay, it's called power. I believe we understand the introduction of the topic. If yes, please let's signify. If you understand the introduction, please kindly signify. Or if you have a question, please drop it in the chat box and let's attend to it together. The concept of power is clear to me. Thumbs up. Okay, Ella, thanks for your response. Yes, I'm expecting others to give me their reactions. So I'll be sure that we are all following and we are all getting what we are doing today. Waiting for your reactions. Still waiting. The concept of power is absolutely clear to me. Please signify. Ella has signified. I'm expecting others also to do the same. We said that power is the time rate of doing work. It's not actually the work, how much the work is, how large the work is. It is the rate at which you have done that work, the time rate that you use in performing that work is what we call power. So that is the concept behind what? Power. And the formula is given as W over T, where W is work done. W is what? Work done. And T is time taken. The time taken. All right. And we still have another formula that says force times velocity. Force times velocity, where F is force and V is velocity. Okay, so these two formula we are going to be using when we start the application of what? Power. All right, and power is measured in joule per seconds, which is also known as watts. Which is also known as watts. Power is measured in joule per seconds. Joule per seconds, which is also known as what? Watts. I believe the concept of power is clear to us. Can we dive in into the next? Can we proceed? Can we proceed to the next? If yes, please signify. I'm waiting for your response. Okay, Ella, thank you for your response. So permit me to wipe the board. Now let's explain the concept of, I'll stop presenting this picture. Let's explain the concept of efficiency. Efficiency the efficiency of any system is a ratio of the work output to the work input. It is a percentage. It is expressed as a percentage. It is expressed as a percentage, and which implies that efficiency is equals to work output over work input multiplied by 100. So this is the expression of what we have. Ratio means division, okay? So when we have ratio, that's work output, what work output ratio, work inputs. Press this, we are going to say work output over work input, because the ratio work output ratio work input, it is work output over work input. Okay, so what is efficiency? Efficiency is efficiency of a system is the ratio of the work output to the work input, and which is expressed as percentage. Okay, and if you want to know how efficient a system is, a system can be anything. Okay, it can be anything. If you want to know how efficient a device is in performing its function, you have to calculate the efficiency by using the formula work output over work input multiplied by 100. And take note, efficiency of any system, any instrument, any device can never be 100%. Why? Because there's always an energy that is being wasted in the process of friction. For a system that deals with heat generation, when heat are being generated through friction, it reduces the efficiency of the machine. Let's take an example. A company like Dangote that produce cement. The machine used in producing their cement is a machine that grinds limestones and different components together to form the cement. And that machine is a system. That machine used in producing the cement in Dangote companies is what? Is a system. Now, the efficiency of the what? Of that machine cannot be 100, even if it is newly purchased. That is, if the machine is a new machine, the efficiency cannot be 100%. Why? Because while the machine is functioning, there is what we call friction that happens within the components of the machine. And frictions reduce the efficiency of any machine. Frictions reduce what? The efficiency of any machine. And that is why mostly or generally we cannot have efficiency of a system, of a machine, to be 100%, but it's going to be less than 100. So it can be 99, it can be 98, it can be 80%, it can be 75%, any other percent, but it cannot be 100%. Okay, so the efficiency of every machine is subjected to a value that is less than 100%. That is less than 100% because of friction. Friction reduces the efficiency of a machine. I believe that is clear to us. Is efficiency clear to us? We want to dive into solving questions. Please, I need your reaction. If efficiency, the concept of efficiency is clear to us, please thumbs up. Okay, thank you, Eli, for your response. Do you have more reactions? More reactions? All right, can we proceed to the application of power and efficiency? Can we proceed? If yes, thumbs up, and we'll move on to the applications of power and efficiency. I'm waiting for your reaction so we can move on. Okay, Ella, thanks for your response. Maxwell, Ruben, thanks for your response. We still need others to react, please. Sulia, thanks for your response. Okay, still waiting for the remaining people to react quickly so we can move on. Your reactions are needed quickly so we can move on. Enoch, your reaction is needed. Abiodun, your reaction is needed so we can move on quickly. We are moving on to the applications of efficiency and power. The application of efficiency and power. Permit me to wipe the board. If you haven't written this down, you can take a screenshot and let's proceed. Application of power and efficiency, bracket calculation. So we are going into calculations. So we are going to consider questions under power and efficiency. Power and efficiency. And to start with, we're going to make use of this question, a UTME question 2001. This will serve as the first application. A working electronic motor, electronic or electric motor takes a current of 1.5 amps when the PD, which is potential difference across it is 250 volts if its efficiency, if the efficiency of that electric motor is 80%, comma, the power is dash. The power output is dash. The power output is dash. So we want to get the power output of this question. That was the requirement. And can you tell me why this is 80? Can you tell me why it's not 100? I need the response. Why is the efficiency 80%? Why not 100? Yes, response in the chat box. Why is the efficiency for this question 80%? Why not 100%? What is the reason behind it? I'm waiting for your response. What is the reason behind it to be 80% and not 100? Waiting for your response. Why is the efficiency 80%? Why is it not 100? Why is it not 100? What's the reason? What's the reason? Because the efficiency of a machine is reduced by friction. Thank you, Ella, for this great response. Because the efficiency of a machine is reduced by friction. All right, now let's go on to solve this question. And to do this effectively, like I've always been saying, physics is very, very simple, but you need to be very careful while solving questions in physics. The first hint is that always read your question, understand your question, and bring out the parameters. The parameters are given information in your question. So when you are done with that, you'll be able to know which one is missing. Okay, and that will lead you to the formula to use. All right, so in the question, they gave us current, and they said current is 1.5 amps. Current, which is letter I, current is represented by I. It is 1.5 ampere. Okay, and they gave us the potential difference. The potential difference, which is PD, we call it PD, and is measured in voltage. Potential difference is 250 voltage, 250 volts. And also we are given the efficiency, which is represented by letter E. It is 80%, 80%. And they said we should find the power output. So let me represent power output. P dot O, power output. P dot O is question mark. P dot O is what? Question mark. So we don't know what exactly is the power output. So we need to get the power output, and we need to make use of the formula for efficiency. The formula for efficiency. Efficiency is equals to power output over power input times 100. Power output over power input times 100. Now, can we just make the power output subject of the formula? Referring back to mathematics where we are talking about subject of the formula, which is also called variable of focus. The variable of what? Focus. So I want to make power output the subject of the formula. Make power output what? The subject of the formula. The subject of the formula. Okay, the subject of the formula. So we have to do that. If this is over 1, when you cross multiply, we have P O, which is power output. All right. Oh, before we do that, there is a multiplication sign beside them. There's a multiplication sign beside them. 100 multiplied by power output, that is E, equals to 100 PO, 100 PO over PI. Okay, now making PO subject of the formula, I'll need to cross multiply. Efficiency will multiply PI. and that will be equals to 100 PO. 100 PO. Okay, so let's proceed. In that case, PO will be equals to efficiency multiplied by PI over 100. Efficiency multiplied by PI over 100. Efficiency multiplied by PI over 100. That will be the formula we are going to use to solve this question. All right. So please, if you are following, kindly put this thing down as we continue with the solution. We are not yet done. You can screenshot and let's continue. What I've just done is that I made power output the subject of the formula. That's what I just did now. And I have not solved anything yet. I'm about to solve the question. Can I go ahead to clean the board? From the question, current is 1.5 ampere. Potential difference is 250 volts. Efficiency is 80%. And power output, which is PO, is question mark. And we have made power output subject of the formula. Power output is now equals to efficiency times power input over 100. So this is the formula I'm going to use. Efficiency times power input over 100. That will be the formula to use. And all I need to do is to substitute this information. The power input, PD, is potential difference. Potential difference. Potential difference. That's the meaning of PD. Okay, we are going to substitute all this inside the question. Now, your PI, which is power input, has to do with the information that were imputed in that electronic motor. Okay, so my PI equals to current times potential difference. PI equals to current times potential difference, which is equals to 1.5 times 250 volts. You need to multiply that. 1.5 times 250 volts. 1.5 times 250 volts. We have 375. 375. 375. That's what we are having. Okay, we need to go back now to power output equals to efficiency is what? What is efficiency in the question? What is efficiency in the question, please? If you are following me, what is efficiency in the question? 80. So that's 80 times PI, which is power input, is 375 over 100. Okay, so we have on 0 cancel 0. All right, we have PI equals to 8 times 375 over 10. Okay, so when you multiply PO equals to multiplying 8 times 375, multiplying 8 times 375, you have 3,000 divided by 10. And when you divide 3,000 by 10, you have 300. So the power output is 300. Now I have a question for everyone. What will be the units of the final answer? We talked about fundamental quantity and units in the first class when we started the UTME crack on this live session. We talked about those units. Now, what will be the unit of 300? Because in physics, if I'm writing 300 as the final answer, that is wrong. It's not correct because it needs a unit. Physics works with units. So there's something missing here, a letter missing beside 300. So what is that letter? What is the unit of power output? What is the unit of power output? Your response in the chat box. Waiting. I'm waiting. What is the response? I said it earlier while I was explaining the concept of power. I said power is measured in what? I gave you the unit of power. I said power is measured in joule per seconds, or what's the other one? Watt. Thank you, Ella. So this is 300 watts, capital W. So the power output is 300 watts. Thank you, Ella, for your response. So the power output is 300 watts. Is that clear to everybody? Can we move on to the next application so we can explain more questions? All right. Permit me to wipe up the board, Application 2. If a cage containing a truck pole weighing 950 kilogram is raised to a height of 90 meters in a minute. In a minute, what is the total power expended? What is the total power expended? This is UTME question 2009. If a cage containing a truck coal weighing 950 kg is raised to a height of 90 meters in a minute, what is the total power expended? What is the total power expended? So we want to find power. And for the previous explanation, we said power equals to work done over time. Power equals to work done over time. And take note that work done can be in kinetic or potential, can be a kinetic motion or a potential. So if it is potential, it will be mgh. If it is kinetic, it's going to be, half mv squared. But for this question, we need to know whether it is kinetic or potential. All right. The question says that take g equals to 10 meters per second square. So when you see this already, you know it is acceleration due to gravity. Okay, acceleration due to gravity. And the hint is that you don't use acceleration due to gravity to solve a kinetic question. No. You use acceleration due to gravity to solve a potential energy or a potential work done question. Okay. So for this, already that we have seen G equals to 10 meter per second square. That means we are dealing with what? Potential, not kinetic. We are dealing with potential. Okay, so in the question, they give us some parameters. Your work done will be mgh because it's potential and G has been given already. In the question, they gave us the what? The weight of the truck, which is the mass. So the weight is the mass. That means that M equals to 950 kg. All right. And they give us the height. The height, which is H, is equals to 90 meter. All right. And they gave us in a minute. A minute means 1 minute. That means time equals to 1 minute. 1 minute. And you should know that in physics, the accepted unit for time is seconds. The accepted unit for time is seconds. So you have to be very, very careful not to go ahead to use one. One is a minute. You have to convert 1 minute to seconds. So 1 minute to seconds, what is our answer? How many seconds make a minute? A minute. 60 seconds. Thank you for your response, Enoch. So this is now 60 seconds. Okay? 60 seconds. Now let's solve the question. P, which is power, G also is 10, as given in this question. P equals to mgh over time. Because your W represents mgh. That's the work done. The work done is mgh. So we have power equals to mass is 950 times G is 10 times height is 90 over 60. So we have mass is 950. The gravity due to acceleration is 10 and the height is 90 and the time is 60 seconds. So let's go ahead to simplify this and we have the last response. 0 here, we cancel the 0 here and let's multiply 950 by 10 and also by 9. 950, 950. Enoch, thank you so much for your response. 14,250. 14,250. You multiply this, and this is going to give you P equals to 14,250. Have you divided already by 6? I think yes, he has done that. So I want to break it down. I will not want to write the final answer. So let me multiply 950, 950, 950 multiplied by 10, multiplied by 9. That is 85,500. 85,500 divided by 6. That will give us 14,250. So the power is 14,250 watts. 14,250 watts. But for the sake of UTME, you might not see this in your option and you'll be seeing something like kilowatts. Your answers will come with kilowatts. And you have to know that kilo, which is K, kilo, which is K in physics, is 10 raised to power 3, and 10 raised to power 3 is what? 1,000. Okay? So if I'm going to express this in kilowatts, I'm going to divide it by 1,000. So if I divide this by 1,000, what we are going to have power equals to 14.25 kilowatts. 14.25 kilowatts. And from the kind of the way UTME is structured, this is what you're going to see in your option. You will not be seeing this. So you need to convert to kilowatts by dividing it by what? 1,000. So they prefer using this kind of options than to use this 14,250 watts. So they will always express it in kilowatts. So your answer is 14.25 kilowatts. 14.25 kilowatts. Is that clear to us? Okay, Eli. Okay, enough. Thank you for your response. So can we wipe the board? Ash, hold on. Okay, take the screenshot and let's continue. Wipe the board. Then we'll move to application 3. Application 3, UTME 2009, 5,000 joule of work done, 5,000 joule of work done on a machine results in the lifting of a load. Result in the lifting of a load of 800 Newton through a vertical distance, 5 meter. Calculate the efficiency of the machine. The efficiency of the machine. So we are asked to calculate the efficiency of the machine. UTME 2009, 5,000 of work done. If I may ask, what is work done? What is the value for work done in this question? What will be the value of work done in this question? What will be the value of work done in this question? The value is 5,000 joule. Work done. That means we are referring to inputs. That is power inputs. When you have done a work, what you have actually do is that you have imputed some power. Okay. When you have performed a work, that means you actually contributed some power. You actually imputed some effort to achieve that work, and that's what we call power input. So the 5,000 joule of work done is our what? Power input. Okay. So my power input is 5,000 joule. Okay, I proceed to read the question. On a machine results in the lifting of a load. So when the power was imputed, it resulted in output of another power, and the output is that a load of 800 Newton was lifted up through a vertical distance of 5 meters. That's the output now. So the power output is equals to, the power output is equals to what? The load multiplied by the distance. The load multiplied by the distance. You know, the load is measured in Newton. So we have load times distance. Load times distance. So what is the load? The load is 800. Power output. The load is 800. 800 times the distance is what? 5. So when you multiply this, you have 4,000. 4,000. Okay? 4,000. Now we can calculate the efficiency using the formula for efficiency. Now that we have the power input, we have the power output, we can go ahead to calculate the efficiency, which is power output over power input times 100. Efficiency equals to 5,000. Oh, sorry, power output should come first. Power output is 4,000. 4,000 over power input is 5,000 multiplied by 100. Okay, by simplification, 0 cancels 0, 0 cancels 0, 0 cancels 0. Efficiency equals to 400 over 5, and that will be equals to 400 over 5 should give us 80. That's 80%. 80%. So the efficiency of the machine is 80%. The efficiency of that machine is 80%. If this is clear to us, please signify. Please kindly signify. Okay, thank you for your response. All right. Can I wipe the board? I have one question for us to solve. Can I wipe the board? Okay, thank you, Enoch, for your prompt response. Given that power output equals to 300 watts and the power input is 600 watts, find the efficiency. Very quick one. Find the efficiency. I'm waiting for your response. Given that power output is 300 watts, the power input is 600 watts, find the efficiency. You should know which formula to use. You have to use the formula for efficiency that says efficiency equals to power output over power input times